All right, we are going to continue looking at proportional relationships, but we're going to compare the relationships, um, comparing tables to graphs, comparing two different situations. This is one of the last main pieces of the proportional relationship unit and kind of putting some things together. So let's take a look at our first scenario. The graph below represents how many chips Rebecca eats in an hour. The equation represents the rate that Layla eats chips. Find out who eats more chips in 3 hours. Okay, so we have two situations here. We have Rebecca's chip eating habits and Layla's chip eating habits. So we need to compare these two situations and find out who eats more chips in 3 hours. So I need to know for Rebecca how many chips in 3 hours, and for Layla, how many chips in 3 hours. Now, a couple things to remember when you're comparing two things. You have to compare things that are alike. Fractions. Comparing fractions. Common denominators allow you to compare fractions because if the denominator is the same, then we have the same level. It's the same type of situation. So if I have, 2/5 versus 4/5, well, I have more fifths here than I have here. But if I'm trying to compare 2/5 to 4/8, fifths are not like eighths. So it's hard to compare them. Okay, so again, we want to compare similar things. So that's why I'm looking at the chips in 3 hours. Because if I look at Rebecca's chips in 3 hours, that's a ratio. If I'm looking at Layla's chips in 3 hours, that's a ratio. And when I make my ratio, it's a number over 3. A number over 3. So I'm looking at rates that are similar. Okay. All right, so let's see if we can find out how many chips Rebecca eats in 3 hours. So we have a graph. We can literally look at the graph at 3 hours. How many chips did she eat? Well, if the hour is 3, the total number of chips is 36. Now remember, we're not going up 1, 2, 3. We have to pay attention to the intervals, don't forget. So in 3 hours, she eats 36 chips. Now look at Layla. Hers is written as an equation. They tell us X is the number of chips, number of hours. Y is the number of chips. So if I need to know how many chips per hour, I can look at my equation. Well, Y is the number of chips. X are the hours. So if I have Y equals 15X, all I'm going to do is substitute a 3 for the X because it's 3 hours. So basically, it's kind of like I'm substituting the number in so I can do the math, like a table. If it's 1 hour, it'd be 15 times 1. If X was 2 hours, 15 times 2. Okay, so I'll replace the X with a 3 because I'm looking for 3 hours, and X is the number of hours. So Y equals 15 times 3. 15 times 3 is 45. So if Rebecca eats 36 chips in 3 hours, Layla eats 45 chips in 3 hours. Who has more chips in 3 hours? Layla. Layla eats more chips in 3 hours. Make sure you're specific. Okay, don't just write Layla. Say Layla eats more chips in 3 hours. Her rate of chip eating is higher. Okay, so again, look at what the goal is, and then how are we going to get to that goal? Let's look at the next scenario. Aaron and Lucia both have coffee shops. The graph below represents how many cups of tea Aaron made and the amount of sugar used. The equation represents how much cups of tea Lucia made and the amount of sugar used. Whose uses sugar at a faster rate? Okay, so we're looking at who uses sugar at a faster rate. So we're not trying to find a specific number like we were in the last problem, okay? But remember, with the rates, especially like unit rates, we have a ratio here of y to x, right? Okay, that's going to help us start. With each of our situations, we can look for the ratio of y to x. And what will happen is, if you remember unit rates, usually if you're asked who uses sugar at a faster rate, you want to find the unit rate. And with the unit rate, remember, it's a ratio where the second number is always 1. So if I look at my ratio, I would need to make the x be 1. X is our sugar. X is our sugar. So if I'm looking at a ratio of the y to x would be cups to sugar. Okay, so I'm just looking at the ratio of y to x would be the ratio cups to sugar. Except we want that second number to be 1. So for the unit rate, it would be how many cups, how many cups of tea, let me move this, sorry. Let's try this again. So finding the unit rate, it would be blank cups per 1 pound sugar. So how many cups of tea for 1 pound of sugar? If I can find that out for Aaron and for Lucia, then I will get my answer. Okay, so again, in these questions where they just ask for who has the faster rate, find each unit rate. Okay, I just gave you like the long road explanation, which is necessary, but ultimately when you get this type of question, you want to find the unit rate. And really, honestly, with all of these problems, if you just find the unit rate, you'll be fine. Okay, so Erin, let's find her unit rate. Well, the unit rate, if we look back over here, how many cups per 1 pound? So I need to find where 1 pound is. The only thing is, I don't want you to guess. Okay, we don't guess or eyeball numbers. We want to go to actual legitimate information. We will find the 1 cup of sugar or 1 pound of sugar. We just have to go roundabout a little bit. So if I look at this point, this is 6 cups for 2 pounds, right? Well, I need 1 pound. Well, if it's 6 cups for 2 pounds, how many cups should it be for 1 pound? It's just making a proportion like you did in 7th grade. 3 cups. So for Aaron, 3 cups of tea use 1 pound of sugar. Okay. Now let's look at Lucia. Our sugar is X. Here's our equation. I want to know my unit rate. How many cups per 1 pound? Well, if sugar is the X, I need to know 1 pound, so I replace the X with a 1. Y equals 10 times 1. Y equals 10. So that means 10 cups per 1 pound of sugar. So who uses sugar at a faster rate? 3 cups of tea for a pound of sugar, or 10 cups of tea for a pound of sugar? Let's think about it for a second, because you got to be careful. Just because Lucia has 10 is bigger than 3 doesn't necessarily mean that that's using sugar faster. Let's think about it for a second. If we each have a pound of sugar and we're each making cups of tea, okay? So you and I each have a pound of sugar, and each of us are going to make a cup of tea at the same time. If I'm Aaron, on my 3rd cup of tea, I'm done with my sugar. If you're Lucia, on your 3rd cup of tea, you still have sugar, right? You're not going to run out until 10 cups. So I am using sugar faster because I have less tea to show for all the sugar that I spent. So our answer is Aaron uses sugar faster. So much of these word problems aren't just plugging in numbers, doing math, getting answers, plugging in, doing math, getting answers like a robot. You really do have to stop and think. Think about what you know. It's not difficult, but you have to think. This was a big one, but it's not difficult. You can do this. All right, last one. Graph below shows the rate at which Melanie listens to songs. The equation represents the rate at which Jessie listens to song. Over a day, who listens to more songs? So over a day, who listens to more songs? Now, if you look here, we have hours. You don't need to figure out 24 hours. I know a day is in 24 hours. But you would be insane. Like trying to go figure out the graph for 24 hours is nuts. But if we find a unit rate, our rates are all proportionate. So if I can find the unit rate for the number of songs, whoever has more in 1 hour is going to have more in 24 hours. Okay, so we're going to find the unit rate. That's the first thing we'll do. And again, like I said before, you can start with the unit rate for all of these. Remember, our ratio is always y to x. So if I look at my situation here, y is the number of songs, x is the hours. Our unit rate is saying my second value has to be 1. So for each person, I'm going to find how many songs in 1 hour. How many songs in 1 hour? That will give me my unit rate. So let's go to Melanie. In 1 hour, 4 songs. Let's look at Jessie. We want 1 hour, and x is my hours. So I'm going to substitute the x with a 1. So in 1 hour, Jessie listened to 2 songs. Over a day, who listens to more songs? Well, in 1 hour, who listened to more songs? Melanie. Melanie listened to 4 songs in 1 hour. Jessie listened to 2. So if Melanie listened to more songs in 1 hour, based on the rate, it's a constant rate of change, that means she would listen to more in 24 hours. It's because everything's a ratio. Okay, there's no Um, in real life, this isn't how it works, but for these situations, Melanie listens to 4 songs every hour. Jesse listens to 2 songs every hour. Melanie will always have more songs that she has listened to. And that's it.